This videotape will show you how to machine keyways using the vertical milling machine. When keys are set in keyways, they provide a positive means of rotating a hub or gear on a shaft. After viewing this videotape, you should be able to write down the safety procedures to be observed in the machine shop and while working on the vertical milling machine, describe the procedures for machining keyways in a shaft, and describe the procedure for machining internal keyways in a hole. When working in the machine shop, always wear your safety glasses. Keep your sleeves above the elbows. Remove rings, watches, and other jewelry. And check all setups for proper clearance before turning on the power. Parallel keys come in two shapes, square or rectangular. Square keys are used in shafts of 6.5 inches in diameter or less, while shafts of over 6.5 inches in diameter generally use a rectangular shaped key. Key stock is purchased in long lengths and can be cut to the appropriate lengths for keys. It usually comes with a negative tolerance to bar stock. The size of the key is usually determined by the diameter of the shaft on which it will be used. This information is listed in the machinery's handbook under key sizes versus shaft diameter. The table shows that as the diameter of the shaft increases, so does the size of the key. After the key size has been determined, the next procedure is to lay out and cut the key seat. The key seat is a rectangular groove in a shaft or hub which is machined to a given tolerance to accept a key. The two types of key seats that will be covered in this videotape are the parallel key seat for parallel keys and the woodruff key seat for woodruff keys. In this demonstration, we will be using a 7/8 inch diameter shaft. The table in the machinery's handbook shows that a 7/8 inch diameter shaft will require a 1/4 inch square key. The key seat, or keyway as it is sometimes called, will be cut with a vertical milling machine. Mount a vise on the table of the milling machine and check it for squareness to the table. The head of the machine should also be checked for squareness to the table. Mount the shaft securely in the vise and leave about a 1/2 inch extending from the end of the vise in order to pick up the cut. The keyway must be parallel to the axis of the shaft and on the center line of the shaft. This means that the center of the key must be over the center axis of the shaft. These are the two tolerances that are usually given for machining key seats. Use a center finder and determine the edge of the work. The center finder must be on the center line with the shaft when touching the sides. This means that it must be on the horizontal center line of the shaft. When the edge has been determined with the center finder, move over the width of the center finder to put the center of the head on the edge of the shaft. Then move over 1/2 the diameter of the shaft to make the center of the head parallel to the center axis of the shaft. With the head now positioned, move the head of the milling machine toward the end of the table. Remove the center finder and insert a 1/4 inch diameter end mill. Select the correct spindle RPM for the head and start the spindle. The correct depth for machining the key seat may be found by using the table in the machinery's handbook, which gives the height of the arc on the shaft. From the tables in the machinery's handbook, we can see that for a 7/8 inch diameter shaft and a 1/4 inch key, the arc would be 0.0182. Adding this value to 0.125, which is 1/2 the width of the key, gives a value of 0.1432. This measurement is the distance from the top of the arc to the bottom of the key seat. The tolerances allowed for keyways are +0 and -10 thousandths. In this demonstration, the keyway could be cut to a depth of 153 thousandths. Bring the head of the milling machine over the shaft with a longitudinal feed and lower it until the milling head almost touches the shaft. Now use the hand feet on the table to raise the shaft up to touch the milling head. Move the work away from the milling head and set the table feed to 0. Raise the table 50 thousandths and using the longitudinal feed, touch the end of the mill to the end of the shaft. After the touch, set the longitudinal feed dial to 0. For this demonstration, we will cut a 1-inch long key seat. Move the milling head in 125 thousandths to bring the center of the end mill over the end of the work. And reset the dial to 0. Using the longitudinal power feed, machine the keyway to a length of 1 inch. Then, using the hand feed, return the end mill to clear the end of the work. Raise the table another 50 thousandths and machine the key seat to a depth of 100 thousandths. On the third cut, remove 45 thousandths, which will make the key seat within the given tolerance. Check the depth of the key seat by putting a key in the key seat and using an outside micrometer to measure over the key and shaft. For an 875 thousandths shaft and a 1/4 inch key, the reading on the micrometer should be 982 thousandths. This reading may be found in the machinery's handbook. Using the formula at the top of the table will yield the same results. This keyway measures 980 thousandths, which is within the 10 thousandths tolerance allowed for key seats and keyways. The next procedure is to cut the key seat in the hub that is to fit on this shaft. This process of cutting shapes on the inside surface of holes is called broaching. The broaching operation is performed with broaches, which are manufactured to fit specific keyways. In this demonstration, we will be using a 1/4 inch broach to cut a 1/4 inch keyway. Broaches are machined to cut to the correct depth in the hole when they are used with the proper bushings and shims. When broaching keyways, the multiple pass method is used. Choose a bushing that fits the bore and place it with the 1/4 inch broach in the hole. Place the assembly in the arbor press and lubricate it with oil. Set the broach slightly down in the hole and then release the arbor press handle. Raise the handle slightly to allow the broach to align itself and then push the broach through the hole. After the first cut, remove the broach and clean it. And place a shim in the bushing. Insert the broach again, lubricate it, and align it with the hole again before pushing it through the hole once more. If more than one shim is needed to reach the correct depth, repeat the procedure. After the broaches have been used, they should be cleaned and put away. When the key seat in the hub is broached to the correct depth, the hub can now be placed over the shaft with the key in the key seat. This provides a positive means of driving the hub of a pulley or gear with the shaft. Another form of key is a Woodruff key. It is shaped like a half circle and has a key number, which designates the width and diameter of the key. This information is supplied in the machinery's handbook under Keys and Key Seats. The key seat in the shaft is cut with a key seat cutter ground to the proper width and diameter to accept a specific size Woodruff key. In this demonstration, we will use a number 406 Woodruff key and a number 406 Woodruff key seat cutter. From the machinery's handbook, the depth of the Woodruff key seat should be 0.2455. This depth has been calculated to allow for the proper height of the key above the shaft to give maximum holding power. To cut the Woodruff key seat using a vertical milling machine, place the shaft in a vise or dividing head with the end extending far enough out of the vise to cut the key seat. Place the Woodruff key seat cutter in the head of the vertical milling machine. For this demonstration, the key seat will be cut 1 inch from the end of the shaft. The first step is to pick up the end of the shaft with the cutter. Move the table so as to position the center of the key seat cutter 1 inch in from the end of the shaft. Pick up the top of the work with a cutter so that the vertical center of the shaft can be determined. Move the shaft to the back behind the cutter. Using the table, feed up a distance of half the cutter plus half the diameter of the shaft. This positions the center of the key seat cutter in alignment with the center axis of the shaft. Use the cross feed and bring the cutter in to touch the side of the shaft. After the touch, set the cross feed dial to 0. Start taking the depth of cut, which is .2455 for a number 406 Woodruff key. Continue feeding in on the cross feed dial until the proper dimension is reached. Move the workpiece back and use the key to determine if the key seat has been cut deep enough. According to the machinery's handbook, the key must extend .0625 above the shaft. For a 7/8 inch diameter shaft, the dimension over the key should be .0625 plus 875 thousandths. This gives the dimension for checking the depth of the key seat. The key seat in the hub is broached in the same manner as for a parallel key. The width and depth of the broach must be cut to fit the Woodruff key. When the key seat in the shaft has been cut to the proper depth and the key seat in the hub has been broached to the proper size, the two parts will fit together. In review, you have seen how keyways are machined in shafts and hubs for parallel keys and Woodruff keys. Keys and key seats are a very positive means of driving machinery and should be used when it would be necessary to remove or disassemble the machine parts for repair.